spotlight here for us. And our next session is about what does this code do? And it's all about hand tracing techniques for iteration and recursion. And this one's not necessarily a specific coding rooms thing, but I think an incredibly helpful session about techniques to do with students to really get them to understand, iteration and recursion in those repeated patterns. So go ahead, Lisa. I'll pass it over to you.
All right. Is my mic working good there?
Sounds great.
Okay, good. My name is Lisa Ryder. I'm a computer science and math teacher in California, and I have been teaching computer science now for maybe 10 years. A lot like Veronica, I kind of got tossed into the flames, and my first year had very little experience. There was no there wasn't as much available then as there is today, and I'm just so excited to hear about Veronica's journey of her first year and how much she took advantage of everything available. So I love coding rooms. Started using coding rooms probably in 2021. I think when we were all remote, I had been using Replit. Replit was switching to their new form. It was just like making me insane that they were doing that in a year when we were all just scrambling to like figure out what we're doing. Coding rooms just like popped up somewhere, and I typed a message to them and I got immediate feedback, and I just like, that's been a continual thing. That's been a huge selling point to me for coding rooms, is that they have grown so much in the 2 years that I've used them, and every time there's a change and I have a question, it's immediately answered. And I just appreciate that so much, because like Veronica said, so many of us are like the only computer science teachers in our schools or even our districts, and there's nobody to ask. And coding rooms solve that huge problem for me, is that there's somebody to ask. And I love that about coding rooms. I'm coding rooms classic, and I've switched recently to the new coding rooms. And so I started using the new coding rooms, and lots of questions and always answered. So I love them. So I wanted to talk today a little bit about analog solutions to things. I do teach computer science A, and I've taught principles for 4 years. I pass that on to another teacher. I've taught programming 1. I also teach a C++ class, and that's the other thing that I love about coding rooms, is that all the different languages are there in one place. So I can have a course for my C++ students. I taught principles in Python, so I could do Python. I can do Java, so everything there in coding rooms, and that's wonderful about it. So we all know that in CSA, a lot of times we have questions, and we know that the CSA exam is on paper, that they have to write code on paper, and they have to answer multiple choice questions on paper. So I think it's not a bad idea to sometimes have our students do things pencil and paper. So I wanted to share some ideas that I have about hand tracing different things. I'm going to start with iteration and just walk through how I teach hand tracing with iteration. So I'm going to share my camera. Hope that works. Yeah, it looks like that works. All right, so here's a iteration question where probably, the question is, what's the result of this loop? And I think a lot of times students try to do this in their heads. They try to like picture it in their heads. And that's fine. And actually, a lot of students can do that. And I never want to stop a student from trying to do that if they can. I don't think that everybody has to hand trace. I think there's a lot of people who don't. But I want to give students a technique to hand trace if doing something in their head is just, they can't do it, or they kind of get stuck somewhere. So here's this is a Java question with a while loop. And I just shorthanded systemed it out to print. And the question might just be, there might be several questions. There might be, how many iterations are there? Or there might be a question of, what prints. So I like to make a tracing table that kind of might answer all of those questions. So my first tracing table that I teach students is pretty involved. And I think that after students do this kind of tracing table, they can shorten it and make a shorter version. And I always tell students, this is just the way that I do the problem. You might have a different way of doing the problem. And I'm always interested to see what students come up with on their own to hand trace. But this is what my tracing table looks like. I always make a column that is the iteration. It's sort of counting which iteration we're on. And then I like to have a column for variables. And in this particular problem, there's only one variable, which is n, but you might have several variables. So in this case, we just have the variable n. Then I like to have a column for checking the condition to see if the loop is continuing. In this case, the condition is here. Sorry, n is greater than or equal to 0. And then I like to have columns for what's happening in the loop. So I have loop body statements. Sometimes there's just one, sometimes there's several. So in this particular case, in the loop body, we have two statements. We have the decrement of n, and we also have the print statement where we're printing n. So that's really what my intro tracing table looks like. And I'll just sort of walk you through what would happen in this problem to this tracing table. And then you can see really easily how you can answer any type of question about this code. All right, so in our first iteration, n starts as 5. We're going to check that our condition is that true or false. And what I do is I just have like a check or not a check. So in our condition is n greater than 0, is 5 greater than 0, that is true. Now in our loop body, what will happen is our n decrements to 4, and then we print out a 4. All right, and then we'll go to our second iteration. Our n is now 4. Is our condition true? Is 4 greater than 0? Yes. N will now decrement to 3, and we will print that out. What students start to realize when they're doing these tracing tables is sometimes like this column is now this column. So a lot of times you'll see in tracing tables, they might like throw out this column, and you'll just like shorten your tracing table by just having this column, because this is just like going here every time, and sort of repeating that information is maybe not necessary. Oh, I'm sorry, going here to n, going here to n. So n is now 3, is n greater than 0? Yes, decrements to do, printing 2. Iteration 4, n is now 2, it's greater than 0, decrements to 1, and we're printing 1. We're going to iteration 5, n is now 1, which is greater than 0, decrements to 0, prints as 0. This is where I think it's really great to do a tracing table. I think sometimes students would have stopped here if they did it in their head, because they would have said, oh, I'm just going down to 0, so it's going to print 4, 3, 2, 1, 0. Also, I think sometimes students, if they don't do the tracing table, might start printing at 5. I don't know. There's a lot of mistakes to be made here. And I think the tracing table really like helps you really see what's actually happening. All right, so on our 6th iteration, n is 0, which still meets this condition, right? N is greater than 0. And it will decrement to -1, and we'll still print that out. And it's not until we try to do the 7th iteration that n is -1 that we no longer meet the condition. So we would break out of the loop at that point. So what has actually happened is we're printing, and notice it's a print and not a print ln. So these are not printing on separate lines. This is actually going to print the 4, 3, 2, 1, 0, -1. That's we'll see as a result of the code. And I think a lot of times it's hard to see that in your head, but if you can break that down into a tracing table, it's like there's no ambiguity. It's just like it's right there. And then again, we can answer questions. There were actually 6 iterations that ran. This was the result. Maybe it might ask, what are the values that n runs through? N runs through these values all the way down to the -1. You know, there's a lot of things to see in the table that I think are super helpful. Sometimes students, I think, are reluctant to make a tracing table because they feel like it's going to take them time. But I have them do tracing tables, and you can see, like, I talked it out, but actually the time that it takes to make the tracing table is very short. And, you know, we know, you know, sometimes students don't want to waste time on a AP question, making a tracing table, but this actually doesn't take a long time to make a tracing table to do it out. So I wanted to do another one really quick with you, just another example of what a tracing table might look like. Well, how much time do I have? Actually, I don't think I'm halfway through my time, right, Joe? At half an hour. So actually, I'm going to do one more just to show you how it might look a little bit more complicated and what a question might look like. This one has several variables. There's an R, an I, an N, and an A. And the question might be something like this. What does this code do for arbitrary values of A and N? And sometimes I tell students, when you're faced with that type of question, what's the best thing to do is just pick some values for A and N, do a tracing table, and see if you can figure out what the code is doing for A and N. So my suggestion for this one was, let's do this tracing table for, let's try A is 2 and N is 4. And then see what happens. All right, so that's sort of a suggestion, is just try and see what happens. All right, so here is what my table would look like. Again, I'm gonna have my iteration. I'm gonna have my variables. In this case, N, I'm not gonna count N and A as variables because I'm gonna say, well, let's treat the N as a 4 and the A as a 2. So those aren't gonna be actual variables. So really I just have R and I. And then I'm going to have my condition, which is I is less than or equal, technically N, but I'm going to say 4 in this situation. My loop body statements are R is R times 2, and I'm going to increment. All right, so first iteration, R starts as 1, I starts as 1. Is I less than 4? Yes. R is now going to be R times 2, so that's 1 times 2. So R is now 2. And I increments to 2. All right, and again, this is again where some people would say you don't really need these columns because they're here. You're doing them again here. It's sort of like a waste of time. But I like, when we start out doing tracing tables, have students start that way. So now R is 2, I is 2. Is I less than 4? Yes. R is now itself times 2, which is 4, and I increments to 3. So now we have iteration 3. We have R is 4, I is 3. Is I less than or equal to 4? Yes. And R is now going to be itself times 2. Oops, R is 4. And that's going to give us 8, and I is increment to 4. And we're at 4. R is now 8. I is now 4. I is less than or equal to 4. Yes. R is now itself times 2, which is 16. And kind of at this point, students might begin to see, especially in the table, that what's happening is R is doubling every time, right? It's multiplying by 2 every time there. And remember, this was what A is, right? So they can see that really what we're doing every time is we're multiplying by A every time. So we're starting with our sort of our base thing, our R, and we're just multiplying by something every time. So that's like seeing that pattern in a tracing table is very eye-opening for a lot of students. All right, so now we're at 16, 5, and this is not true anymore. So there we've stopped. So now we've ended up that with R is 16, and I asked students, what's the relationship between the 2 and the 4 and the 16? And students are like, oh, well, we're just like kind of multiplying by 2 every time, right? R is getting multiplied by 2. So we can sort of see a pattern there and figure out, for arbitrary values, we're just, we did that 4 times. We sort of multiplied by 2 4 times. So students can sort of get the idea that this is really A to the N is what's happening here. All right, so that's sort of iteration. And again, that doesn't take a huge amount of time to make that tracing table. And it might be much quicker than just trying to think of things in your head. Where I love hand tracing really is recursion. So that's iteration. And just really quickly want to talk about what recursion might look like.
Before
If
that, Lisa,
you're,
we do have a question in the chat.
oh, I'm sorry,
That's okay.
in the chat?
Yeah.
Sorry, I'm like sharing my screen. I can't see the chat.
Yeah, that happens. I can read it for you if it's easier to.
Oh, I love that suggestion. Is that the one you're talking about?
Yes, exactly. It's just the one at the bottom there. By
Let's
Tim.
see. Do you always just substitute values and not include them in the tracing? Oh, I think you could. I think you could trace this with an A instead of how I did it. I mean, there's so many different ways to trace. And I think that maybe showing students using the table with the A instead of a substitute value would be helpful as well. Maybe after you did it once with the 2 and the 4, now let's go back and do it with just an A and R and see what happens there. And like, it really gives students that sense that there's a way to tackle these problems. You know, there's not, you don't have to just look at it and go, well, I have no idea what that does, so I'm just gonna not do this problem. Like, there's a brute force method to, let's tackle it and see what happens. And it really, like, it doesn't, the time is not huge there. All right, so I want to show you some recursion. Let's see if I can find, okay, so here's my first recursion problem that I do in class with them. And I talk about what recursion is, that it's a recursive method or function is one that calls itself. So there's usually a base case, what we call base case, which will like break you out of the method. In this case, here's our base case, that if A is less than or equal to 0, we break out of the method by doing return. Otherwise, we have a recursive call where the method is calling itself. And if you can do a hand trace of recursion, you can solve any recursive method. Like, a lot of times, I feel like when I first started teaching this, I remember reading a prep book that said, you know, there's only 2 or 3 questions on the AP test about recursion. So, you know, if your students don't get it right away, just tell them to skip those problems on the AP test. And I was like, that's nuts. That's a crazy approach to that. Let's give students an actual strategy for tackling these problems, because I really think they're not that hard if you have a strategy. All right, so let's look at I'll just show you my strategy. And again, I tell students, this is just my strategy. You can develop your own strategy. And I'm always intrigued to see what students come up with of how they come up with a recursion tracing. All right, so what I like to do is maybe the question is, what is the result of recur 1 where the argument is 6. All right, so this is how I set it up. And I tell them to leave like a lot of space to do the recursion. So I have my call to recur 1 of 6. And I say, okay, well, if I go into that method, 6 is not satisfying this. So it's not going to do the if statement. So it's going to do this. So it's going to return 3 plus recur 1 of 6 minus 2, which is 4. And then I say, well, we don't know what that is. So that is going to call the method. So this itself is another method call, which is going to call it with a 4. So now we're going to go into recur of 4, which is not less than 0. So it's not going to do that. So that is going to be 3 plus recur 1 of 4 minus 2, which is 2. And we don't know what that is yet. So that is going to be its own call, which is going to go into the method now with a 2, which is also not less than or equal to 0. So that's going to be 3 plus recur 1 of 2 minus 2, which is 0. And at some point, it's going to happen that you're going to hit the base case, which is going to happen right here. This does hit the base case, and we return 0. And then we just have to walk backwards up through our sort of trace. So this returns 0. So this whole thing here is going to be 3 plus 0, which is 3. So that's going to be 3. So this whole thing is now going to be 3 plus 3, which is 6. which means this call will be 6. So our result is 9. Ta-da, you're done. And really, again, it doesn't take that long to do that recursion by hand, instead of just like staring at the problem for 10 minutes and trying to figure out what to do. Some of the recursion ones that I love have to do with like if there's print statements. So I think I have a few more minutes. I'm going to just do, is that okay, Joe? I'm going to do one more. I don't,
You're
are
doing
there any
great.
questions in the chat I need to do?
No, nothing yet.
All right. So this is public void. I'm just going to call it M2. And it takes in int A. Actually, you know what? I have this one written out. Here it is. Sorry. So mystery 2 says if A is less than or equal to 1, we print system.out to print ln, the word dog, else you call mystery A divided by 2, and then you print out cat. So this has sort of 2 things that happen. So sometimes it's hard for students to figure out what happens there. So let's say what the question is, what happens if we do mystery 2 or mist2 of 10? All right, so I tell my students, leave a lot of space below here. All right, so what happens if we do mist2 of 10 is it's going to go in here. It's not less than or equal to 1. So it's going to go in here and 2 things happen. It's going to call mist2 of 10 divided by 2, which is 5. Then we don't know what happens there. But when that call finishes at the very end of that, so I say leave a lot of space. When this call finishes, there's a printout of cat. All right, so now we have to figure out what happens here. So again, not less than 1. So again, it's going to call mist2 of 5 divided by 2. Now this is integer division. So 5 divided by 2 is 2.5. So that's actually just going to be 2. If you're not familiar with integer division, the decimal is truncated there. We don't know what that does, but after that call finishes, again, we'll print out cat. This one, what does this do? Well, that's going to call mist2 of 1. When that finishes, it's also going to print out cat. Remember, because after each of these calls, it prints out cat. And what does this one do? Well, that one is actually equal to 1, so that prints out dog. And then it prints out cat. So what will actually print, and the way I like to set this up so that students can see what will actually happen, what will actually print in order. So this call, does this call, which would print out dog. When that call is done, it prints out this cat. So now that is all complete. So this is all complete. That will print out that cat. That's all done. So that will print out that cat. So you'll have dog, cat, cat, cat. So I just think it's a great visual. And again, that didn't take that long to write out. It happens very quickly. So I just wanted to, let's see, just show you how I might use coding rooms with this kind of hand tracing technique. I did throw into the coding rooms PD day a couple things that might be helpful to you. Let's see if I can get in there. Yeah. So I didn't talk about truth tables, but I threw in a truth tables worksheet that you might, if you do any kind of truth tables, another hand tracing technique. So in coding rooms, if you're old school, a little bit like me, and you still have some worksheets that you like to do with students by hand, you can put those worksheets into coding rooms as a PDF, just like you would into like a Google Classroom or Canvas or anything like that. I did this 2 ways. I put the link, the direct link to my Google Drive, and I also just embedded the PDF there. And then also, if you were excited about, and then I put the answers there for you guys if you are interested in how to do truth tables. once I would walk through hand tracing techniques with my students, I would have them do some practice. And what's great about coding rooms is you can make your own practice, but these are just iterative tracing practice that I pulled out of CS Awesome. So how Veronica showed you how you can like copy and paste things from CS Awesome, I just went into CS Awesome and pulled out, a few of their sort of iteration problems that they have. And what's, beautiful about this is these problems are already done for you. You don't have to make them up. They're already there for you. So I just pulled a couple out and threw them in, into a place where after I did my lesson, students could then go into coding rooms and practice, on their own, some multiple choice questions with immediate feedback for them. I threw in here also, again, the recursion worksheet that I use after I walk through recursion with them, if you're interested in that. So again, I gave the direct link. I gave the actual worksheet and I gave them the direct link. And then one thing, and then here's the answers as well. So you can check that. And then again, I did some more practice that I grabbed from CS Awesome. So I have just recursion practice. So once I taught them some recursion, here's some recursion practice they could do by hand. And then at the end of that, just because I thought I might be interested in seeing what students were doing, in coding rooms, this was something I just recently discovered, you can have them upload a file. So if they were doing stuff by hand and you wanted to see it, you could have them upload. Here I just said upload a PDF, a photo or scan of your hand tracing work. So if students were doing these by hand, they could upload they could take a picture of their work and upload it into coding rooms. So we can still do a little bit of old school stuff with them, even in coding rooms, which I think is just wonderful. And then, they can upload it there, and then you can have a really good view of like, what other techniques are students doing? And then what's really cool about this is you could share it. You could look at it in grid view if you have the paid version and see, and you could share that out to other students. You could put this into presentation mode and share out what other kids are doing with each other, how they're tackling hand tracing as well. So that's it. I think I went over a couple of minutes. So.
Yeah, no problem, Lisa. Thank you so much. We have one question I think we can go over from Randy here asking, are you giving them a hard copy? And is this the way you're using coding rooms, like a learning management system type of thing? Is that typical for your practice?
So usually, like in the classroom and when we're in person, I would give them a hard copy of the 2 worksheets, especially the truth tables ones. I would give them that one. I've kind of mixed up, since we've come back from being remote, I've kind of mixed up giving them hard copies or just posting it online like this. And there's sometimes that I feel like I actually want them to write on it. And if there's something I really want them to write on, I give them a hard copy, because I feel like if I just put it online, it's just like they're focused on the screen and not on the hard copy itself. And that's why it's nice to have the ability to have them take a picture and then upload it to something like coding rooms. We also have Canvas at my school, so I've had students turn in things via Canvas, but I'm kind of excited about this idea of not using Canvas and completely using coding rooms because of all the things that are available in coding rooms now and keep coming available.